Hello and welcome to Golden Droplets episode 14. My name is Ricardo Valls. I'm the founder and president of Valls Consultant, and I'm also a professional geoscientist registered in the province of Ontario with over 36 years of international experience. Today, I'm going to start a new mini-series in these Golden Droplets webinars. We are going to be talking about unusual sampling and exploration techniques. I really hope you will enjoy it. And the first episode will be related to the use of drones in geology. Hello, my friends. I'm here at Griffis McOuat with my good friend Nick. And operating the camera is my other good friend Ricardo Franco, who we thank him for helping us with this little video. I'm going to be talking about Nick's favorite toy, this little drone. You won't believe it, but this is a drone that weighs 250 grams. And I was telling Nick that at the beginning, I never liked drones. For me, it's just a toy, especially the big ones. But once I saw what this little guy can do, I was converted. This is something that you can put in your pack sack, okay? And you are in the field and you look to the mountain, you see a very nice outcrop, but there is a river in between. You get wet or not. So you just take your little drone, you fly it there, you look at the rock, and then you decide, okay, this is an outcrop that is worth getting wet with. The other thing, as I will be showing later, is that we can join our iPhone with the many applications, geophysical applications I mentioned before in the previous Golden Droplet episode, like the Teslameter, and obtain an incredible geophysical map of an area. So I want to pass the microphone to Nick, and please explain us a little bit more about the drone, how it works, etc.
Thank you, Ricardo. This is the DJI Mavic Mini, the latest model. It's a very small. Its weight 249 grams, which is 1 gram less than the requirements for the license. That means you don't need any license for North America. This is the size if you want to see how big is the drone, basically. This is in centimeters, and you can see how big is in this size, like from the top. It's a very small, you can fit in your pocket. This is the remote control, also very small, and you need the phone, which is attaching to the remote control, to basically control the drone. How it works, it's very simple. Yeah, just open those things. You're taking the cover for the gimbal. This small guy can fly in the sport mode with 13 meters per second, or approximately 40 kilometers per hour. Elevation can go maximum, I think, is around 500 meters, half a kilometer. Minutes flying time, which is pretty good, pretty amazing for this small guy. And the range can go like 1.5 to 2 kilometers, which is also very good. me show you how this is working like that. This is the remote control sticks. Just open. You open this way. You attach your cell phone.
That's the part that I like the most, because you don't need an extra screen. You're using your cell phone to fly it.
After that, you just turn off this guy like that. Turn off the remote and start the application. It's a DJI application connecting the remote control to the drone. And now we are ready to fly. It's a real time showing you what is visible on the camera on the drone.
Take off.
Very simple. Just put this stuff up, and the drone is going up. And basically, the good thing is this drone have a sensors and GPS, real-time GPS. That means you know exactly where you are by the coordinates, and you have a sensor showing you how many meters is above the surface on the screen. And you can see everything which is drone seeing. You can put the camera down if you want to do a photogrammetric picture. Basically, we are trying to use this drone, which is the price is approximately $400 US or 600 Canadian. We are in Canada, for professional work or remote sensing for geology and geophysical and geomatics purposes. It's very easy. Just up, down, go front. Now I can rotate the drone like to us. And what we can do, I'm going to put the video camera and we can have a video coverage. There you go, we are three of us. Going a little bit to us, putting down. And now we are going to try to land the drone down. It's very easy, just press down and it's automatically landing. The drone also have the option, if you lose the signal, it's coming directly to the place you start. That means if you send it 2 kilometers and it's a very rough terrain and losing the signal to the remote, it's coming directly to the place where you start automatically.
Yeah. Another thing is that you can control a fixed elevation of flying, so this is very good for your physical measurements. So if there is a ravine, it will go down. If there is
Basically
a mountain,
following
it will
the
go up.
terrain.
You follow the terrain.
Okay.
Okay, that's
Perfect.
it.
Good.
Perfect.
Test number 1.
That's number 1.
Can you move it?
Yeah. Turbulencia.
Test number 2.
Let's
This time we'll try on top of the drone.
with cue and music.
Absolutely.
Trasera de mi corazón.
Let me see if this is gonna work.
Let's go. De su balcón. Okay, fly test.
Number 2.
I would say if it's a fail.
Yeah, the balance I think should be on the back. Did I broke the propellers? Yeah, we have to do it on an open space.
Yeah.
Like that.
Let's go to the other room has more space.
This should be on the back.
Okay, step number 3. What are we trying to do here is to fly my iPhone that has a Teslameter, so we could do a geophysical survey actually using the phone. I will call that a success. Touchdown. Step number 4, measuring the Teslameter. I will call this a successful test. So as I explained last time, once we finish doing the survey, we can email ourselves the result of the Teslametry as an Excel file, as a CSV file. This is the raw data, how we receive it. And here I just clean it up a little bit. I just left the XY, that would be the UTM East, UTM North, and the actual value of the teslametry, the macro Teslas. And here you can see, even in a short fly, as this demonstration, that we have a very nice variability of the data. Now, how does that looks in a map? For that, I use Surfer. And first of all, this is a graphic with the disposition of all the points. There are about 1,400 and something points that the machine measured during the short flight. I did a variogram for all the data and adjusted the line using the power method, and it gives us an anisotropy of 2 and an angle of about 167 degrees. Then using this, I did the gridding using the natural neighbor method, and look at the amazing map that we can get. So another interesting application that we have, if you remember when we were talking the last time about the GPS Motion X GPS application that records our tracks, and you can then export the data to Google Earth or as an ASCII file that you can use in detail. Well, one of the things that you can do is, while the phone is measuring the Teslas, you can also have GPS working to determine the track and the elevation. I'm going to show you. So you go to your GPS, and I have here, I'm going to show you a track from a fly in Mozambique. That is the record. And if I click on View Details, you can see down here the elevations of the track. So you can share that information by email. You select all the emails that you want, and you send that information to yourself. And then you can plot it, as I said, you can plot it directly on Google Earth, or you can extract the elevation values and do your own digital elevation maps. My friend Nick Paskalev is studying the possibility of extracting the same information directly from the drone. If he is successful, I will probably add a note to this video. Second video, I will be explaining also this option. So, as you can see, you can run several applications at the same time. In this case, Motion X GPS and the Tesla.